You know, from the beginning, Yellow 13 Ace has always been about designing and building paper aircraft that were much more beautiful and capable than traditional origami designs. To achieve this goal, good design has always been at the heart of Yellow 13 Ace. This meant creating things with the utmost attention to detail, from material selection to the geometry of the design itself. And it's this care and passion for designing and engineering something compelling, something innovative, that led to the development of the YX-09 Aerius. YX-09 Aerius is the first aircraft that I've designed to incorporate multi-sweep, a newer, more capable variable sweep mechanism. With this mechanism, YX-09 Aerius can adjust its wing sweep from plus 30 degrees to minus 45 degrees. Forward sweep, or plus 30 degrees, could allow for more maneuverability and better vertical launches, while backward sweep, or negative 45 degrees, could allow for better horizontal flights. With this greater degree of freedom in wing sweep, a more diverse range of flight characteristics can be achieved within a single platform. To actuate this movement, a new mechanism needed to be designed. In previous iterations of my variable sweep mechanism, the straw push rods within the fuselage housing are directly linked to the wings. While this direct connection enables precise wing sweep adjustment, it cannot work beyond 0-degree wing sweep, as tension between the straw and the wing forbids any further movement, especially since the wing pivots are also located forwards of the straws. This is fine in aircraft like the F-14 Tomcat V3, where the wing sweep only goes up until about negative 15 degrees. However, it would not allow for the versatility that was required for the YX-09 Aerius, which needed to be able to transition into forward sweep or positive degrees of wing sweep. A solution to this problem would be to use gears. However, this design solution presented several issues. The gears were too complicated to make, the weight and complexity of the design far outweighed the benefits, and it was an untested system. The solution that I've ultimately come up with is a new multi-sweep mechanism. Combined with the friction lock module from earlier variable sweep aircraft designs, multi-sweep eliminates the tension problem as seen with the F-14 Tomcat V3 and allows for the push rod to move freely within the wing spar when the wing angle is adjusted. And because this design integrates the push rod straws with the wing spar, the wings not only become more structurally sound, but also become more durable upon impacts, as the wings are linked to the internal friction lock module, which absorbs the energy of the impact. In addition to multi-sweep, the YX-09 is also the first aircraft I've designed to incorporate the new friction retract mechanism. Like the friction lock mechanism, the retractable landing gear design takes advantage of friction to hold its moving parts in place. The differences between the two mechanisms are that now the parts involved include paperclip and a straw instead of two straws, and that is how the friction works to stabilize the rotational movement of the landing gear. With this new design, the landing gear will not collapse easily as it did in the YX-01 Nightbat V2, in which the landing gear were simple bendable straws. And due to the geometry of the landing gear, they double as additional vertical stabilizers underneath the fuselage. With multi-sweep and friction retract, YX-09 Aerius is by far the most innovative and capable aircraft design in the Y-13A fleet. The design has the ability to be both a forward swept wing and a conventional swept wing, which would in theory make it suitable for different flight modes. And now with friction retract, YX-09 Aerius can be displayed as a desktop model without a separate aircraft stand. I don't think I've ever created an aircraft that is as beautiful, as functional, and as compelling as the YX-09.